Okay, question number 12, maximum mark 19 points. Complex equation, complex questions. Okay, solve this equation, giving your answer in the form of z equal r cosine theta plus I sin theta. This one can be expressed as -1 minus square root of 3 of I can be modulus is 2. You know the argument, this is in third quadrant, and tangent theta, tangent angle 1 root 3 is pi over 3. So in the third quadrant, pi over 3, so it should be 6 minus 2 pi over 3, right? And we can also always add the 2 and pi over here. So let me rewrite this. Z square is -1 minus square root of 3i equal, we can say that 2 cis minus 2 pi over 3, we can always add 2 and pi over here. And then this one also can be, so we can say z square equal 2 cis and put 3 on the denominator, and we got 6n minus 2 pi, like this. And then we put half power on both the left and right side. We got finally z equal square root 2. So modulus will be square root 2, and argument should be 6n minus 2 over 6 pi. So from here we can say that z, putting 0 on the n and the first, so z should be square root of 2. Putting 0, we got minus 2 over 6 is 6. Minus 2 over 6 is minus 1 over 3 pi. And also z equal square root of 2 cis, putting 1 over there. 1 is 6 minus 2 is 4 over 6 pi, so 2 pi over 3. And then we have to show this kind of format. So we can say that the answer for z, so z should be, first one is root 2 cosine minus 1 over 3 pi plus I sine minus 1 over 3 pi. This is the first answer. And second answer is equal root 2 2 pi over 3 cosine 2 pi over 3 plus I sine 2 pi over 3. So this is the answer for the first question. Okay. Let z and z1, z2 be the square root of -1 minus square root of 3i, which is the answer for the fourth question. Real part of z1 is greater than 0. Let z3 and z4 be the square root of -1 plus square root of 3i, where z3 is real part of z3 is greater than 0. Expressing your answer in the form of z equal a plus bi, which is Cartesian form, where ab is a real number. Find z1, z2, and deduce z3 and z4. So we already got z1, z2 over there. So we can say z1 is root 6 minus 1 over 3 pi, which is that one. So, okay. So we can start from here. So z1, because cosine 1 over 1 pi over 3 is real part is greater than 0. z1 is, this is z1 and this is z2. So z1 is root 2 cosine minus pi over 3. What is, how much is it? Is 1/2, right? Plus I sine 1 over 3 pi over 3 is negative negative, okay, root 3 over 2i, and z2 should be root 2 times cosine 2 pi over 3 is a negative 1/2 minus plus sine 2 pi over 3 is equal to pi over sine pi over 3, which is exactly root 3 over 2i. So simplifying this, we will have root 2 over 2 minus square root of 6 over 2i, and then we got minus square root of 2 over 2 plus square root of 6 over 2i. So this is the answer. Okay, deduce z3 and z4. So z1, z2, z3 and z4. Okay, because z3 and z4 is square root of this number. This number is this number reciprocal. This is change conjugate of this complex number, conjugate number. So what all changes? This one changes plus, and that means this one is becomes a plus over here, and plus over here, and plus over here. That means we can have 6m plus 2 on top. So we put 0. So first answer will be z3 will be because this is plus 6m plus 2, putting 0 there will be square root of 2 cis pi over 3, right? And z4 should be square root of 2 cis this is plus, putting a minus 1 there, we will have 6n plus 2, putting minus 1 over there, we got minus 6 plus 2, so minus 4 over 6 pi equal to minus 2 pi over 3. So minus 2 pi over 3. And then they want us to z3, z4 in the form of a Cartesian form. So say that put more space here. Z3 should be square root of 2 cosine pi over 3, which is what is it, 1 over 2 plus I sine pi over 3 is square root of 3 over 2. This is root of 2 cosine minus 2 pi over 3 is exactly as cosine 2 pi over 3, which is minus 1/2 plus I sine 2 pi over 3 is a negative number of sine 2 pi over 3, which is okay minus square root 3 over 2. So simplifying this, we got the square root of 2 over 2 plus square root of 6 over 2i, and then this one we got minus square root of 2 over 2 minus let's get rid of this, minus square root of 6 over 2i. So this is g3, this is g3, and this is z4. So this is answer for the second question. Okay, this time the full root of z1, 2, 3, 4 are represented by the point A, B, C, and D respectively on the Argand diagram. Plot A, B, C, D on the Argand diagram. And then second question is find the area of polygon formed by these 4 points. So these 4 points, as you see, there are 4 points, z 1, 2, 3, 4, 1, 2, 3, 4, right? Z1 is cis minus, it's all square root of 2. The modulus is all the same. Argument is only different. This 4 angle, right? So all we can do is we can draw an Argand diagram. This is rear part. This is imaginary part. We know that all that modulus is the square root of 2, so we can just draw a circle over here, and then square root of 2 over here. It's right on the circle. Okay, first angle is negative 1 over pi. So first angle negative pi over 3, so which is this point here. So this is a z1. So they say z1 is as a, right? z1 is a. And second point, and then we know that this angle, okay, I draw that. This angle is minus pi over 3. Second angle z2 is 2 pi over 3. So 2 pi over 3 right on the opposite of this angle. So over here, this point is a B. So this angle over here from here is 2 pi over 3. C point, Z3 is, C point is over here, square root 2 pi over 3, which is this angle here. This is C point. C point, this angle is pi over 3. And D point, and the same way, point D must be located over here because it says this minus 2 pi over 3. So this angle, so small space, minus 2 pi over 3. And this is point D. Yeah. Okay. So plot A, B, C, D on the arc diagram. I plotted, okay? Find the area polygon formed by these 4 points. So question B answer. So these 4 points makes one rectangular like this. They want us to find the area of this triangle. So as you see, it is all square root of 2 over here. So all the radius is always square root of 2, right? So at the point C, we got the, yeah, let's coordinate. Yeah, this is coordinate, right? So this coordinate point C. So the x coordinate of point C, the real part coordinate is square root of 2 over 2. So you can say this color. This x coordinate is square root of 2 over 2. And then this x coordinate over here is minus square root of 2 over 2. And the y coordinate over here, which is imaginary part, is square root of 6 over 2. And over here, it must be minus square root of 6 over 2, the area. So therefore, the area is, the length of bottom is this length is this minus this, so we got the square root of 2 times height length is this number minus this number equals square root of 6. We got square root of 12 equal 2 square root of 3. This is the area. Okay. Next question. The 4 points Z1 to 3 and 4 satisfies the equation of this. The 4 point of 4 roots of this equation. Okay, the 4 roots of each one of these is reciprocal. Satisfy the equation of PQR whiskey to the 4th power to the equation. Find PQR. This is called palindromic, something like palindromic equation. Since you see that Z1, 2, 3, 4 are the roots of these equations, so this equation is always true for Z1, 2, 3, and this 4 root, this is always true. So what you can do is we just multiply on both sides of 1 over Z to the 4th power. And the equation we get by doing so, we got 1 plus 2 times 1 over Z squared plus 4 times of 1 over Z to the 4th power equals 0. So because this 1, 2, 3 Z 1, 2, 3, 4 is the root of this equation, multiplying this already also makes sense. So this is also root of that equation. So root of these equations are yeah 1 over z1, 1 over z2, 1 over z3, and 1 over z4 is also equation of that equation. So transforming, we can set the whiskey w is 1 over z. We got the equation. We got the equation 4 times w to the 4th power plus 2 times w to the squared plus 1 equals 0. And equation of this root is w1, w2, w3, and w4 are equation of for this equation. Also, w1 is defined as 1 over z1. This is 1 over z2, and all the way like that. Okay, so this is the answer. So this and this is the same. So we got the P equal 4, Q should be 2, R should be 1. Okay. The for root 1 over z1, 1 over z2, 1 over z3, 1 over z4 are representative of point E, F, G, H, respectively on the Argand diagram. Find 1 over z1 in the form of a plus bi. So, okay, 1 over z1 is 1 over z1 is 1. Z1 is where's z1? Z1 is this form, right? Z1 is this form, which is this form. So square root 2 cis minus pi over 3. So square root of 2 cis minus pi over 3. This is 1 over z1. And then modulus of this one becomes 1 over square root of 2. Argument is cis. Because top part 1 can be expressed as 1 cis 0, right? So 1 and square root of 2 makes this one, and cis 0 minus this one will be the new argument, which is pi over 3. So this is the 1 over z1. Hence, deduce the area of a polygon formed by these 4 points. So similarly, see that 1 over z1, 1 over z1, the modulus change, every modulus changed to 1 over square root 2 now, but the argument change is conjugate number. So z1 from here becomes, this number becomes 1 over square root of 2 cis 1 pi over 3. So modulus changed to this length. Argument is a reciprocal number. Argument is not reciprocal. Argument is a conjugate number, right? Conjugate. So what you can say, we can draw now 4 points in the Argand diagram. So this A point here, this A point changed to new argument. We go over here, and the modulus change it to this ranks now 1 over square root of 2 from 2. So we can imagine there will be a 4 point formed in the Argand diagram. Something like this. And then A go to E, so E over here. And then B go to F, B go to F. So this should be F. And then C go to G, C go to G. So this is G. And then D go to H. So this is H. Now the modulus change, this modulus, all modulus change to this length is changed to 1 over square root of 2. But the shape of area, shape of this rectangle is always the same. So the deduced area, the area should be, because the length becomes from length. Original length was square root of 2, changed to 1 over square root of 2, which is this is equal to square root 2 over 2. The length change on half, right? Length change to by half. The area is gonna change by that half, that number squared of original area, which was 2 root 3, equal, it's going to be 1 over 4 times of 2 root 3 equal, it's going to be 3 square root 3 over 2. This is new area.